Hello everyone. In this video we're going to be solving an IMO long list problem from 1971. This problem was proposed by Germany at the time. So we have the following system and we're going to be finding the values of x, y, and z. I would like to start with this sum of the cubes. So let's go ahead and write our famous identity. As you know, this polynomial, and we've done some videos on this, is divisible by x plus y plus z. And we can write it as follows. So this gives us the first part. We know the value of x cubed plus y cubed plus z cubed. So let's go ahead and replace it with that. And let's make some substitution here. For example, I would like to call the xyz. I want to call that p. And then I'm going to be using xy plus xz plus yz, and I would like to call that t for two-way sums. And then I'm also going to be dealing with x plus y plus z. I could call that s, but I do know that s is equal to 3 here. Great. Let's go ahead and do the replacements. 15 minus 3p is equal to 3 times the quantity given that way. Now, here what can I do for x squared plus y squared plus z squared? I can write it as x plus y plus z quantity squared minus 2 times xy, xz, yz. And then when I subtract another one like that, it is going to give me, the second factor is going to give me 9 minus 3 times xy plus xz plus yz. But since I call this t, I can basically replace the second factor by 9 minus 3t. And that is going to give me actually a nice expression in two variables. Let's go ahead and simplify this. 15 minus, actually at this point you could probably divide both sides by 3. That should give you 5 minus p equals 9 minus 3t. And if you put the, p and the t on the same side, or you can actually do the following. Let's go ahead and isolate p from here. P is going to equal 3t plus 4. Actually, it's going to be minus 4, right? Because we're going to be bringing the 9 over to the left-hand side. That's going to be a minus sign. Great. So we can write the p as basically 3t minus 4 here. Great. Now let's go ahead and do something else. I would like to get the, the sum of fifth power. So I would like to use x cubed plus y cubed plus z cubed and multiply it by the sum of the squares. But here's the thing. When I do this, I'm going to be getting the fifth power, but I'm also getting extra terms, right? Like what? This should give me x to the fifth plus y to the fifth plus z to the fifth, right? And then plus, I should be getting something like x cubed y squared, and then x squared y cubed plus x cubed z squared plus x squared z cubed plus y cubed z squared and y squared z cubed. So we're going to simplify this expression a little bit. I do know that this sum is equal to 15, so I'd like to find something for the sum of the squares. But if you remember, here we actually found it, right? Even though we didn't write it down that way. This is equal to 3. 3 squared is 9, and we call this t. So we can actually write this as 9 minus 2t. Okay? 2t or not 2t. Anyways, so now from here, and we know that this is equal to 15. So we're getting the following. 15 multiplied by 9 minus 2t is equal to the sum of the fifth powers, which is equal to 83, by the way, plus, now, here I'd like to use some factoring. For example, I can take out x squared y squared, and that's going to give me x plus y, and then I can use x squared z squared. That's going to give me x plus z, and then I can use y squared z squared with y plus z. Okay, great. Now I'd like to find something else here, but let's go ahead and distribute first. And then I can subtract the 83. And the right-hand side now can be arranged. How? We can basically make it factorable, but first I'd like to do the following. I can replace x plus y with 3 minus z. Why? Because x plus y plus z is equal to 3. I can replace x plus z with 3 minus y, and I can replace y plus z with 3 minus x. So I get the following. because I subtracted 83, I get x squared y squared multiplied by 3 minus z plus x squared z squared times 3 minus y, and y squared z squared times 3 minus x. And now, if you subtract, you're going to get 52 minus 2t. And now on the right-hand side, if you distribute, you're going to get 3 times this quantity. So we can take out a 3 and write it as x squared y squared plus x squared z squared plus y squared z squared. And then minus, and that can be factored as well, because you're going to be getting x squared y squared z, and we can factor out an xyz here, and then inside the parentheses we're going to get xy plus xz plus yz. Great. So now the only thing that remains here is pretty much finding an expression for this. Now, how am I going to simplify this? But we can actually find an expression for that. Let me show you how that can be done. We can actually take this expression and square it, right? When we square it, we're going to get what we need, plus some other terms. That should be a z squared. As you know, plus, now we're going to be getting something like 2 times x squared yz, plus 2 times y squared xz, plus 2 times z squared xy. And then, since this is equal to t, we can say that t squared is equal to this expression, x squared y squared plus x squared z squared plus y squared z squared, plus 2xyz multiplied by x plus y plus z. Now we do know that this is p and this is equal to 3. So what we're looking for here can be written as t squared minus 6p, because 2 times p times 3 is going to give us 6p. Great. Now let's go ahead and replace that expression here, and replace this with p and replace this with t. Let's see what we get from there. This is going to give us 52 minus 2t equals 3 times the quantity, which is t squared minus 6p, right? And then we're going to be getting minus pt. Great. So we got the following equation. Obviously, this can be simplified a little bit, and we have another equation that we can use, which we got here. P equals 3t minus 4. P equals 3t minus 4. So this is our system, and we're going to solve that system. Let's go ahead and solve it. Okay, I'd like to simplify the top part, and let's see what we can get from there. So 52 minus 2t equals 3t squared minus 18p minus pt. Let's go ahead and replace p with this, 3t minus 4, and we're going to get the following. 52 minus 2t equals 3t squared minus 18 times 3t minus 4 minus t times 3t minus 4. This is going to give us 52 minus 2t equals 3t squared minus 54t plus 72 minus 3t squared plus 4t. Now, at this point, we can go ahead and simplify the quadratic terms. Awesome. And then we can put everything on the left-hand side, like the variables, and the numbers on the right-hand side. Great. So I get negative 54 plus 4, which is negative 50t. And if you go ahead and, add that to both sides, you're going to get the following. So I'm getting, let's see, 52 minus, let's go back here. Okay, so I think I forgot to do one thing here. Let me go ahead and fix that real quick. So when I distribute, it's supposed to be 30t. So this is a 30t. This is a 30t. Let's see what changes we're going to make here. There we go. This is supposed to be a 30t instead. Okay. And then everything else is also going to be 30t's. Okay, let's go ahead and fix these. Okay, this is going to be 30t, 30t, and 30t. Great. Okay, I think that fixes it. Now, we can go ahead and put, let's see, negative 50t plus 50t. So that's going to give me 20t here. And if I subtract the 52 from the 72, I'm going to be getting 20. Awesome. Yay, I got the value of t. From here, I'm getting t equals 1. Awesome. If t is equal to 1, we knew that p is equal to 3t minus 4. P is going to be -1 from here. So I got the value of p, I got the value of t, and I also know that s is equal to 3. Awesome. You know what that's supposed to mean? I know the sum of x, y, z, which is 3. I know the two-way products, which is t, and I know the product, which is equal to p, and that's -1. So it's kind of like using Vieta's formulas, but kind of backwards. We can basically write a cubic equation which satisfy these conditions. Let's go ahead and write it. And let's use the variable u, something that's not x, y, z. So u squared minus x plus y plus z is equal to 3. So it's actually not u squared, u cubed. Minus 3u squared plus, actually I can kind of tell you what that looks like first so that you know how to write it. If basically, here's what I'm going to do. I'm going to write u cubed, so here's what I'm going to do. Okay. U cubed minus the sum, which is 3u squared, plus the two-way products, which is u, and then the constant will go here. Okay, so that is my equation. Actually, this is supposed to be a plus sign, and we're going to be solving this. How do you solve this equation? And when you solve this equation, the roots are going to be x, y, z. Let's go ahead and solve this. So I can write it as, notice that u equals 1 is a solution. Yay, awesome. So I can write it like this. U cubed minus u squared minus 2u squared plus 2u, happy birthday to you. Okay, great. Minus u plus 1 equals 0. And then u squared times u minus 1 minus 2u times u minus 1 minus 1 times u minus 1. And that gives me u minus 1 times u squared minus 2u minus 1 is equal to 0. And from here, we're going to be getting u equals 1, u equals 1 plus root 2, and u equals 1 minus root 2. Basically, those are going to be the x, y, z values. And you can basically say that by writing it as a set, you can kind of avoid writing all these order triples. So the x, y, z values are going to be the following values. And that's going to give us the solutions, all the real solutions. And this brings us to the end of this video. I hope you don't mind. It was a long video, but this was an IMO long list problem. Thank you for watching. Please let me know what you think. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.